Now we will discuss a chapter named Projectile Motion. So here I say a particle launched with certain velocity in any arbitrary motion under the influence of gravity is called as projectile. In any arbitrary direction under the influence of gravity is called as projectile. So we have following assumptions. Assumption 1, the surface of Earth is more or less flat. The acceleration due to gravity is constant throughout the motion. And number 3, we have no air drag is present. Now here it says the surface of Earth is more or less flat. The acceleration due to gravity is constant throughout the motion. No air drag is present. So following examples, we can say a batsman hitting a cricket ball, a football is being kicked by a football player, or a food packet is being dropped by an airplane. So there are many examples related to projectile. So we have like the path followed by the projectile is known as trajectory, which is parabola. We will prove it. So path followed by the projectile is known as trajectory, which is a parabola or parabolic in shape, because we don't consider the rotation of, or another we can say, or another assumption we can have, rotation of Earth is neglected when we consider the problems related to projectile. So now we will consider types of projectiles that we will consider while discussing some few problems for JEE Mains as well as JEE Advanced. So the 3 types of projectiles are: number A, horizontal projection or horizontal projectile. In this projectile we consider here the projectile is thrown in a straight way with constant velocity u, and g is acting in this way. So there is no acceleration along x direction because the body is thrown with a constant velocity u. Later on we will explain this. Number B we will have, or number B I will have here, oblique projection. Oblique projection means, examples I give you. This is an oblique projection. This is also an oblique projection. G is still acting. And this is also an oblique projection. G is still acting. This is oblique projection. We will consider in few classes. Number C will have projectile or projection on an inclined plane. Like here we can have this projection on an inclined plane in this way. We will consider horizontal projection and we will discuss first equation of trajectory. That means I take this coordinate axis. I consider any point P, like this is X, this is Y. G is acting constant throughout the motion. So in this equation of trajectory, I consider any point P on the path followed by the projectile or path of its trajectory. So since the body here, the body is thrown with a constant velocity u, so I can write in time t where it reaches the point P, I can write x is nothing but ut, and since there is no initial velocity along y direction, so I can write y is equal to half gt square. So this is half into g into t, I can write x by u whole square. So this is half g x square by u square. If you look carefully, this is a equation of parabola. Now we will discuss about velocity at any instant. Any instant means I want to represent velocity in time, in terms of time t. So here I say, since here ux is always constant, that is u, and uy will be nothing but g into t. So v vector becomes ux I cap plus uy j cap. So I say this is u I cap plus gt j cap. So v vector mod becomes u square plus g square t square whole root over, and if theta is the angle made by the particle with x axis at any instant, so I can write tan theta is equal to vy by vx, that is gt by u, that implies theta is equal to tan inverse gt by u. Now if h is the height where the projectile lands and t is the time to reach the ground, and r is the horizontal distance, or we say is equal to range, then I can say h is equal to half gt square and r is equal to u into t. So I can write here, instead of t, that implies t is equal to the third point is deviation suffered by projectile. Now, if there would not have been any gravity, this particle would have been going straight forever. But since the gravity is acting, so gravity pulls the body. Suppose at any point I say this is the deviation suffered by the projectile, where I can write y is equal to half gt square, or half into g into, I can write this x by u whole square. Same when we discuss the first point, equation of trajectory. This is the deviation suffered by the projectile.